the chapter sets properly, half of your math class will become easy. So therefore, today I will make this chapter extremely simple and exam ready for you. So in this chapter, which is titled Sets, we will cover section 1.2, and then in the next video we'll cover the next section. Section 1.1 is basically just introduction, brief history on it, so that's why I skipped it, so we could jump right into the task at hand. And so we are going to introduce what sets are. Our goal for this video is to understand the definitions, the notions, and representations, right? So next is, what is a set? How do we define what set is? So set is well-defined collection of objects. Objects must be clearly identifiable. For example, if we list A, I, O, U, we cannot say that they're alphabet letters. We have to be very specific. So we would say set of vowels, okay? So that's what makes set well-defined. Next is well-defined versus non-well-defined. So well-defined, it has a clear membership. So for example, rivers of India. We could, define each of the river, and we know exactly how many there are. Well-defined, it's something that is ambiguous, which is not clear, okay? So for example, famous mathematicians. Well, this is not well-defined because it's asking about most famous mathematicians. So we know that as we go through time, the famous mathematicians will change. So if you were, talking about present, mathematicians who are famous might be different from someone who is from, let's say, 1900s. So therefore, it's not well defined because it's not clear. Unless the examples so in order to make this more well defined, we could say most famous mathematicians in 1900s. So that's something we could search and find out. So it becomes more well defined because now we added a time slot to it. Next, there are key terminologies that we need to understand that are used throughout the book. So it's to your best interest for you to know these terms right away and be familiar with them. So objects is the same as elements, which is same as members. So all these terms mean the same thing. So if someone might use the word object, the other might use elements, the other might use members, but they all mean the same thing in sets. And elements belong to a set. All right, so we will go more in detail as we progress forward as to exactly what set is or how it looks like. And the notion of sets. So now sets are denoted by capital letters, as we could see in the example below, A, B, C, X, Y, Z. Which letter we use doesn't matter as long as it's a capital letter. Whereas in elements are denoted by small letters, right? And again, which doesn't matter which one you use, which letter you use. So if you're gonna define a set, capital letter, elements, small letters. And then the important symbols that we need to be aware of is this symbol right here. This symbol right here is an epsilon sign, which means belong to, okay? So we would read this as A belongs to A. So we know A is element because it's in lowercase and the set is capital A. B does not belong to A. So that's how we would read this. Again, B is lowercase, so it's an element. A is capital, so it's a set. And these show memberships. Next symbol is these two dots, which are known as colon in our English class. But in math, colon means such that. So anytime we see a colon, we're gonna say such that. And then we have parentheses, which means set of all. So the parentheses represents the set of all. So now we'll look at an example of membership. So here it says V, which is capital, so we know it's a set. What is a set of? Vowels. And that is the other reason we used V, just to make it easier to show that it's vowels, okay, and not just the alphabet. And we put the parentheses sign to show that it's set of all. Okay, so set of all the vowels in the English alphabet. Then we have A, which is elements. So elements are these right here that are in the parentheses. So here A belongs to V, which is true because A is in the set of V. B, the letter B, is not part of this set. So therefore we say B does not belong in V. Okay. Next, methods of representing sets. There's two methods. One is called a roster or tabular form, and the other one is called set builder form. Okay, so these are the two forms. And then roster form, it lists all the elements inside the parentheses. Okay, so roster form lists all the elements inside the parentheses, which are separated by commas. And as we learned in the previous slide, that anything that is within those parentheses means elements. Okay, it could mean elements, objects, as we learned earlier. So for example, on the bottom we're given 2, 4, 6. So those are the even numbers, okay, that are contained in that set. Next, roster form examples. So we could say set of divisors of 42. So you could be asked a question like that, where you have to put it in a roster form. So what you're going to do is list all the numbers that 42 can divide into. So 1, 2, 3, 6, 7, 14, 21, and 42. So all these numbers in here are divisor of 42. Okay. Then moving on to the next slide, we have to keep note that the order does not matter. So if we write 1, 2, 3 in a set, or write 3, 2, 1, or 2, 1, 3, doesn't matter. So order is not important at all. Okay, so it's just convenient sometimes we find it to write it in order, especially when it came to the last example of divisor. This way we could make sure we covered them all, but otherwise it does not matter. Okay, so for example, if you were to list vowels A, I, O, U, it doesn't matter which order you put them in. Okay, so it wouldn't matter. The other thing that we have to keep in mind is no repetition, which means that if we were to write the elements that are not repeated. Okay, so if we were to write school, since there's two O's, we would only write one of the O's. Okay, so no repetition means that if element contains same element more than once, but we only write it once in the set. Okay, so school actually has 6 letters, but in our element set it only has 5 because O is used twice. Okay, then infant set. Infant set, just like the word explains, infinity goes on forever. So some sets that go on forever. For example, if we were to write it, we would just let's say we were writing all the odd numbers. Okay, so we would just write parentheses and then put 1, 3, 5, and then put ellipses. Ellipses are these 3 dots that show continuation. That means the list goes on and on. And whenever you're writing infant sets, I would recommend that you write at least 3 elements before you put the ellipses to show continuation. Okay, this shows the teacher that you understood what the requirement is and you understand the pattern, and so you could get the full points. Next is set builder form. So this is the second form of sets. Set builder forms is defined set using properties. Okay, so here we're defining what the sets are. We're not listing them. So in builder, you're just writing what the set is and not listing things. So for example, here we're saying set V is, so you would read this because as we learned before that these colon means such that. So we say V is equal to X such that X is a vowel. Okay, so we're defining what X is. We're saying X represents a vowel. Okay, X is a variable, so it could be A, I, O, U. So it could be any of those vowels. Then an example of set builder that we're given is showing that set A has X as the elements such that X is natural number and it's less than 3 or greater than 3 but less than 10. So those numbers would be 4, 5, 6, 7, 8, 9. So if I were to pick any of these elements and put them in here, this statement will become true. So let's say I pick 7. Okay, so 10 is bigger than 7 and 7 is bigger than 3. So it works. If we were to put 4, 10 is bigger than 4, 4 is bigger than 3. So it works again. And you could read it the other way as well, that 3 is greater than 4, which is less than 10. So either way, as long as it follows the rules. So we're going to do some conversion practice. So it says converted to roster form. Remember, roster is list. So we're told that set A has X element such that X is even and is less than 10. So therefore we would list all the even numbers up to 10, and those would be our answer. And we're not going to include 10 because it doesn't have an equal to sign. So if this had an equal to sign, we would put 10 in our answer. But since it does not, it says X is less than. So our numbers have to be less than. and they have to be even as well. So those are the two conditions that are well defined for our set. All right, moving on to the next one. Some quick tricks. Make sure that the set is well defined, so it's not ambiguous like we had where it says most famous mathematicians. And because mathematicians could be famous at different times in different part of the world. So someone who's famous in math right now in US doesn't necessarily have to be famous in, let's say, Norway. Okay, so that's why we have to be very clear as to the set is well defined. As we discussed before, order does not matter when we're listing the elements. And you want to avoid repetition, meaning if something is being repeated, you only list them once in the sets or in the elements. And we use properties for larger sets, okay? And then the common mistakes that is seen among students is repeating elements. Sometimes they forget, or sometimes they, like if we were to write Mississippi, they would skip some letters and kind of forget to skip the others. So you have to be careful to make sure that you're not repeating any of the elements. It's only stated once. So the best way to approach that is when you have the word Mississippi to cross them out beforehand and then write what's left over. This way you can make sure that everything that's being repeated is crossed out, and whatever is left will be your set of elements. Ignoring the order rule. Again, any order doesn't matter. And make sure that you interpret the colon as such that. So when you're writing an answer where you're given an example and they ask you to write it in words or something, you would say such that, okay? And here are some practice questions that we are told to write in roster form. So remember, roster form is listing. So number 1 says even numbers less than 12. So that's number 1. Number 2 is multiple of 5s less than 30. And number 3 is vowels in English. So I'm going to give you some time to write those answers. And you could pause the video and then we'll go over the answers. Alright, so hopefully you have them all. So even numbers would be 2, 4, 6, 8, 10. And then multiples of 5s would be 10, 15, 20, 25. And vowels in English, A, I, O, U. Alright. And that brings us to the end of this video. And I just want to share that in the next videos will be mini videos. We will go over 12 ways that the question can be asked based on this chapter. So each mini video will have one set that covers 4 to 10 problems that we will solve together, okay? So be sure to subscribe so you could be notified right away when the videos are uploaded. And if you like the video and want one-on-one tutoring, click on the link that's in the description to our website. Thank you.